Hello everyone, welcome back once again. In this video, we are going to learn how to represent a given irrational number on the number line. And at the end of this video, I will give you some work to do. So please try those works at home. Okay, here we have the number line, okay, and how to represent the rational numbers or any whole numbers or any natural number. It may be positive or negative, any integer, how to represent these numbers on the number line. This is not the matter of discussion because you have already learned these all things in your earlier classes, isn't it? It's a very simple task for you, but in this video we are going to learn how to represent irrational numbers on the number line. Okay, so this is going to be interesting one for you. So here I have the first question: represent root over 2 on the number line. So how will you represent root over 2 on the number line? So this is extremely new task for you because till now we have not learned how to represent this root over 2 on the number line, isn't it? So for class 9th standard students, those are beginners. For the beginners, this is going to be interesting one, how to represent root over 2 on the number line. So for which I will show you step by step. First of all, you have to take a ruler, okay, take a ruler and a pencil, then draw any line with any measurement, put arrowhead. Since number line never end, so both the sides it is must, that means you have to put the arrowhead on both the sides of the number line. And suppose consider there is 0 of the number line, then this side there will be positive numbers and this side there will be negative numbers. So let us mark certain points at equal intervals, equal intervals, okay, equal intervals, and we will name it as 1 unit, 2 unit, 3 unit, etc. This side also let us mark certain points, equal intervals. Then if you go that side, that it will be 1 unit, then it will be 2 units, it will be 3, it will be 4, and this side it will be -1, -2, -3, and so on, isn't it? It will be 1 unit. So we have considered this number line. On this number line, we have to represent root over 2. What to do? We will take this 0, okay, as 1 point, and this 1 as the second point. That means 1 unit. We have considered 1 unit. After this, at this point, at this position, we will make it as point A. And at this position we will draw another line perpendicularly, okay, another line perpendicularly, keeping in mind that perpendicular line must also be not more than 1 unit. It must be 1 unit only, exactly 1 unit. How to draw the perpendicular line? See, the longer line of the ruler must fall on this line, straight line, okay, the number line. Then automatically your line will be perpendicular, and make it exactly 1 unit up to here, 3 to 2 or 2 to 3, this is 1 unit only, okay. So from 0 to A, this is 1 unit. From A to another point, suppose it is B, it is also 1 unit. After that we will join 0 and B, we will join 0 and B. Then you will notice that we have a perpendicular here. So that means it is what type of triangle? It is a right angle triangle. Triangle OAB is a right angle triangle, isn't it? So right triangle, RT triangle. Triangle, what is the name of the triangle? OAB. RT means a right angle triangle. OAB implies, what does it imply? OA equals to what? OA equals to 1 unit. AB equals to again 1 unit. Okay, then if you apply Pythagoras theorem to find out its hypotenuse, Okay, this is 90 degree and the side exactly opposite to 90 degree, that is this, the longest side of a right angle triangle, it is known as hypotenuse. Okay, let us find out the length of this hypotenuse, that is OB, applying the Pythagoras theorem. If you have remembered the Pythagoras theorem, yes, that was hypotenuse square is equals to perpendicular square plus base square. Okay, what is hypotenuse here we don't know, but the name we can put, that is OB. OB square is equals to, what is P perpendicular, what is perpendicular, what is the measure of perpendicular, that is 1. We have the value, perpendicular AB is equals to 1 unit. So perpendicular AB, that is 1 unit. So as square is there, so we are writing here square. Then base OA, what is the length of base OA? Length of base OA is also 1 unit. So we will write here 1, as square is there, so we will put square. Alright, then it is OB square, let it be. Then 1 square is 1, you know. This is also 1 square, this is also 1, you know. Then OB will be, if you remove the square from here, then there will be root over 1 plus 1, all of you know that is 2. That means OB, the length of OB is 2 units. Root over 2 units, sorry. Root over 2 units. OB is root over 2 units. OB, where is OB now? Yes, there is OB. Is it lying on the number line? Of course not. It is not lying on the number line. Now, what to do then? This is our number line. This is the number line. Remember, this is the number line. But OB, whose length is root over 2, it is not lying exactly on the number line. Now, what to do then? Yes, the only way is there. We have to take the help of a compass. With the help of a compass, we will put the sharp end of the compass at O, then the other end at B. Then draw an arc. This arc will touch or cut the number line at a certain point. This length will be exactly same as that of this length. If this length measure root over 2, then obviously this length will also measure root over 2. That means from O to this point, say the name of this point be P, this length is equals to root over 2. And now our root over 2 length is this. It is slightly more than 1, isn't it? So root over 2. In this way, root over 2 is represented on the number line. And this is the verification also that OP, this is root over 2 or not. The mathematical verification is also done. So hope you have understood how to represent root over 2 on the number line. After this, we will try to represent root over 3 on the number line by the similar method. See, here I have written the question, that is represent root over 3 on the number line. And I have already drawn this number line, previously drawn. This is the 0 of the number line, this side -1, -2, and that side that is 1, 2, 3 and so on. As the number line never ends, that's why both the side, it is must that you have to put the arrowhead, this side and this side. Is that clear? Now the similar process. From this to this, there is 1 unit. Okay, this 1 unit, this 1 we will name it as point A. Clear? Now 0 to 1, there is 1 unit. We have to represent what? Root over 3 on the number line. Clear? How to do? Yes. At point A, at a distance of 1 unit from 0, we will draw another perpendicular line. Another perpendicular line. Let us draw this. How to draw the perpendicular line? As I said in the previous construction, that is the longer line of this 2 must fall on your number line. Then automatically your ruler will be perpendicular to the number line. Is that okay? Now from this point you will draw a line, that means a perpendicular not longer than 1 unit, exactly 1 unit you have to draw. See, from 2 to 1, okay, it is 1 unit. So we have drawn here also 1 unit. Remember, downside it is 1 unit. If you want to check, then look at Is it 1 unit? Yes. From 0 to 1, this is 1 unit. And the upper side also it is 1 unit. That means, look at, isn't it 1 unit? So this side, on this side you have to take 1 unit each. This is 1 unit and that is also 1 unit. Clear? Now let us name this point as B and join OB. If you join OB, you will get a triangle. Okay, and as already you have learned in the previous construction while constructing root over 2, while representing root over 2 on the number line, that this is 1 unit, this is 1 unit, then this length, that is hypotenuse, it will be root over 2 unit, isn't it? Yes, it will be root over 2 unit. Now what to do to draw and how to draw root over 3, how to represent root over 3? We are asked to represent root over 3 only, but we have represented, or we have constructed here root over 2. Now what to do? The immediate next step will be, you have to draw another perpendicular at exactly the point B. At this point you will construct one more perpendicular. How will you construct the perpendicular? How will you draw the perpendicular? Remember, your longer line of the ruler must lie now on this hypotenuse. Look at, this is lying or not? Look at minutely, very carefully you look at. This is the longer line of your ruler. It must lie on your hypotenuse. Once you keep your ruler like this, the ruler will remain perpendicular to the hypotenuse OB, that means. Okay. Now draw 1 unit this side. 1 unit, exactly 1 unit you draw. Once again 1 unit. Remember, you have to draw the perpendiculars. Yes, 1 unit. Perpendiculars, 1 unit. Remember, perpendiculars, 1 unit you will draw. Clear? This is also 1 unit. Let us name this new point as point C. After that, let us join the point C with O. Once you do so, you will get this figure. Now, let us check what is the length of this line, this hypotenuse. Yes, as you have already learned in the previous construction root over 2, that this line, this hypotenuse, its length is root over, yes, root over 2. Then what will be this? Let's see. First of all, for triangle OAB, we will draw once again, okay? For right triangle OAB, what do we have? OA is equals to 1 unit. Similar way, AB is also equals to 1 unit. I am not writing here 1 unit. Unit, okay? After that, we will find out OV, since it is a right angle triangle. So we can apply Pythagoras theorem to find out the length of OB. So how to find out OB now? You have already learned that hypotenuse square is equals to perpendicular square plus base square. Okay, what is hypotenuse here? OB. Yes, OB square is equals to perpendicular is 1 unit and base is also 1 unit. Now OB will be equals to, removing the square root from there, root over will come, 1 square, you know it is 1, and this is 1 square, this is also 1. That means 1 plus 1 is 2, that means root over 2. OB is equals to root over 2 units. We can mark it here as root over 2. Is that okay? Now, one more triangle we have, that is OBC. OBC. Let us take this triangle. What kind of triangle is this? As we have here perpendicular, that means 90 degree. What type of triangle is this? Yes, it is also a right angle triangle. So, in this right angle triangle, we have the base root over 2 and the perpendicular 1. Then what will be the length of this hypotenuse? Let us try to find out. What is the name of the triangle I said? Yes, that is OBC. In triangle OBC, or we will write for right triangle OBC, what do we have? Let's see. OB equals to root 2. OB equals to root 2 units. Then, what is that? BC. BC equals to root 1. BC is equals to, only 1. Isn't it? Now, we have to find out OC. As OC is the hypotenuse, how it is hypotenuse? How do you come to know that it is hypotenuse? Yeah, that's a great question for you, I think. Yes, nothing. If it is 90 degree, then the side opposite to 90 degree is known as the hypotenuse. This is hypotenuse then. Okay, that means the longest side of a right angle triangle is the hypotenuse. Later on in the geometry session, we will prove that the longest side of right angle triangle is called hypotenuse, or it is the hypotenuse. We will prove in geometry session under chapter 6 or 7. Okay. Now, length of hypotenuse, that is OC, we are going to find out. Again, the same method, that is Pythagoras theorem, we are going to apply. Okay, what is the hypotenuse? OC. So hypotenuse square is equals to, what is the base here? OB. OB square plus what is the perpendicular here? That is BC. I have written like this, okay? BC square. Now hypotenuse square, let it be OC square. What is OB? What is the length of OB? That is root over 2. Root over 2 square. What is BC? BC is 1 unit, so 1 square. Now, removing this, okay, let it be for now, root over OC whole square. Root over 2 square. Root over 2 square, you know? Root over 2 square. What does it mean? Yes, it means that root over 2 into root over 2. And when you multiply 2 times root over 2, it will be exactly root over 4. And all of you know that root over 4 is 2. So we are writing root over 2 square as 2. Clear? So root over 2 square means 2. Yes, root over 2 square means 2 plus it is 1 square means 1. So 1 plus 2, all of you know it is 3. Then removing this square from OC here, what will it be then? Root over 3. That means length of OC is equals to root over 3 units. Root OC, length of OC equals to root over 3 unit. Now let's see. OC, where is OC? OC, that is root over 3. And what was our task? Our task was to represent root over 3 on the number line. Now my question is root over 3 on the number line? Of course not. It is not lying on the number line. This is, here it is, the number line. And the root over 3 is just above or on the number line like this, but it is not lying exactly on the number line. It is perpendicularly almost or vertically standing on the number line, or not, or slightly slanting way it is standing on the number line. So this root over 3 is to be brought here. So how will you do that? Yes, your compass will help you to do so. Now take your compass. Yes, take your compass. Keep the sharp end of the compass at point O and the other end of the pencil at point C. Then draw an arc such that the arc touches the number line. In such a way that the arc touches the number line. As you have noticed, the length from O to this point, let us name this new point as P. Alright, now as you have noticed, that length of O to this new point P is equals to length of O from point C, that is root over 3. Okay, and as it is root over 3, this will also be root over 3. That means from O to this new point P, this length is now root over 3. And in this way, we have represented root over 3 on the number line. This is root over 3. And it is its mathematical verification also we have done here. Okay, so hope you have enjoyed, you have understood. And if you have any problem, you can give me comment. Now as I said that I'll give you some tasks to perform at home. So you try these tasks. Okay, the first task is verify that root over 4 is equals to root over is equals to 2. Root over 4 is equals to 2 by construction method or by representing root over 4 on the number line. As all of you know that root over 4 is a rational number because it is equals to 2, and 2 is a whole number or rational number. So it can be represented on the number line very easily in the form of 2. Okay, root over 4 is equals to 2. Even though this is to be verified that root over 4 is equals to 2. You know that root over 4 is equals to 2. Okay, by division method also you will get the answer, but this is to be verified by the same method, the method that I showed just now. What to do? The same method you have to perform. You have to take a number line, then take 0 here, then 1 unit you need to mark. After that, go on constructing. Up to root over 3 you have to do. After that, one more perpendicular line, then draw an arc. It will touch exactly at 2. Okay, your curve must touch exactly. Suppose if it is 1 and if it is 2, then your curve must lie or must touch point 2 on the number line, because root over 4 is equals to 2. Okay, so do this. After that, one more task I will give you. Some more questions are there, a few more questions are there here. Look at represent root over 5 on the number line, represent root over 6 on the number line, represent root over 7 on the number line. Okay, if you go on representing these all, you will get a spiral. Okay, square root spiral. That means, suppose this is the number line and you have started constructing, and if you go on constructing like that, you will get a square root spiral of this kind you will get. And it is very interesting one. Okay, so you practice it, try it, and if you get any problem you can comment, you can share, and those who are direct in contact with me, they can practice and can share their problems in my WhatsApp numbers. Okay, thank you very much. I hope you have understood this new thing today.